you're one
exactly.
of
I submitted a talk here.
Who submitted a talk, and so the funny thing is also we kept on speaking English all the time, even though both of us speak German. For me, it doesn't make any difference because none of those languages is my mother tongue, anyways. And so yeah, I'm really keen on learning about GraphQL because I've heard stuff about it, but I still have no actual clue about what it actually is.
Good stuff.
So let's give a round of applause for Nikolas.
All right. Yeah, thank you, Staff. Thank you for the introduction. All right, can we switch the screen to my slides, though? That would be helpful.
You have to comment on the video.
All right, GraphQL for native iOS developers. That's the title of the talk. Before we get into the actual talk, so I really want to get a feeling for the audience here and for like who has already heard of GraphQL and who has worked with GraphQL. So who has heard of GraphQL? Raise your hand. All right. Maybe it's easier to ask who has not heard of GraphQL yet. All right, still a couple of people. That's very nice. Okay, who has used GraphQL either with Swift or with any kind of other technology? All right, we actually have people who've used it. Who has used it with Swift? One person with Swift. Okay, so that's really good because that is really the main part of this talk. I actually prepared like a large practical part where I'm going to show you and we're going to build a small application with GraphQL and with Swift. All right, so who am I? My name is Nikolas Burk and I work at a company called GraphQL. We are a startup based in Berlin and we are basically building a backend development platform for GraphQL and serverless technologies. So we kind of have this idea of a backend as a service. So if you're just a front end or a mobile developer, you can just use our service and have your completely production-ready backend with a couple of clicks. And then I'm also a tutorial author at the Ray Wenderlich website, which I assume all of you are familiar with. Let's take a look at what we want to cover today. So first, I want to give like a brief introduction to GraphQL, but this is really not a conceptual talk today. It's a very, very practical talk, so I'll keep that part very, very brief. Then I'm going to explain how you can use GraphQL together with Swift using the Apollo client, and then we'll get into the demo. So let's start with the GraphQL introduction and the big question, what is GraphQL? So in short, it's a new API standard that was developed and open sourced by Facebook in 2015. So it's really only 2 years old. But Facebook already started working on GraphQL in 2012. And they actually have already been using GraphQL since then in their native mobile apps. So if you remember back at the time, the Facebook app actually was this weird HTML5 app that had a lot of problems, and when they decided to rewrite this application, they were also using GraphQL for that. And despite the fact that it shares the same suffix with SQL, so it's a query language, but it does not really have anything to do with a database. So it's not a database technology, and that's a really key part to understand. It's a query language for APIs, not for databases. And it basically enables a declarative way of fetching and updating data, a declarative way of working with APIs. So it provides a special syntax that allows a client application to describe some data requirements, send that over to a server. The server is going to resolve these data requirements and send back the result to the client. Let's take a look at a simple example. So let's assume we have a conference planner app with a table view that should display a number of conferences. So in such a situation, we would typically have like one REST endpoint that you could access, something like /conferences, that would return an array of conference data. And here the conference, here each conference has an ID, a name, a city, and a year, and then we got a whole bunch of conferences that we download into the application and that we can then render inside a table view. But maybe we also, since it's a conference planner app, we also have the concept of an attendee. So an attendee can attend a conference. So if we want to download all the attendees for a specific conference, we would have to go and access like a REST endpoint that might look similar to this. So /conferences, then the ID of the conference of which we want to download the attendees, and then /attendees. And this might just return the attendees that have been registered for this particular conference. All right, so now we have this view and we can perfectly render it with the /conferences endpoint because that gives us exactly the data that we need. But what if our designers now say that the app would be a lot better if for each conference we could actually also display the last 3 people who registered for that conference? So what are the options that we now have? Essentially, the first option would be to adjust the API. So here is what the data that the server is going to return looked like before. But if we wanted to actually customize it for this particular use case now, we would have to go and tell our server engineers to make it something like this so that we include the information that we need on the screen in the payload that we receive from the server. So this would be one way out of that situation. But this really won't allow you to iterate quickly on your designs if you make changes frequently and you want to incorporate user feedback and you have to adjust the API every time that you need different data for a particular screen. And then potentially you also have multiple apps who have these requirements and these situations. You just have to work a lot on the backend side. And this is not really a scalable approach that you want to have. So the second option would be you just go with the way how the API is designed at the moment, and you have to send n+1 requests. The first request is to get all the conferences so that you get all the conference IDs. And then you have to load the attendees for the first conference, the second one, third, fourth, and so forth, and until you get all the attendees so that you can display them inside the application. All right. So this is also not really a desirable situation because we're making a lot of network requests and downloading a lot of data, even though that's not really all required inside the application. So how would we solve the same situation with GraphQL now? So with GraphQL, we could essentially specify what's called a query and send this query over to the server. And here is a really important point that you have to realize when you compare REST with GraphQL. So with REST, we usually make use of the different HTTP methods that we have available, in particular get, post, put, and delete. So if you have a REST API that makes use of these methods, it's generally a well-designed REST API. And with GraphQL, on the other hand, we don't really care about the transport layer. We could actually build a GraphQL API with another transport layer than HTTP, but the most common implementations of GraphQL are using HTTP, and there it works in the way that you attach a query to the post request that you're sending to the server. So you're always sending post requests to the server so that you have more space where you can put the query. And then the server is going to go and resolve the query for you and send back the data that you've been asking for. So what does the query now look like for this particular screen? Essentially, we would specify a query like this, where we ask for all the conferences, and then we can exactly specify what is the data that we need for each conference. So we want the name, the year, the attendees, in particular, the last 3 attendees of the conference, and then we want the ID and the name of each attendee. So this is really a much, much better way, because now we can clearly specify on the client side what kind of data we need from the server. Before we get into the demo, let's talk about 2 really important concepts that you have to know when working with GraphQL. And the first one I just mentioned, that's a query. So a query you send over when you want to just fetch data from the backend. Here we have a query where we are asking for one particular conference, and we're asking for the name, the city, and the year of that conference. The server response could look like this. So we receive a blob of JSON data, and this root field there is called data because that's specified in the GraphQL specification. So every GraphQL server response always has to have this root field. And then in there, we have exactly the same shape in the response that we specified in the query. So here we have exactly the same keys that we now get returned from the server. And then we also have the concept of mutations, because usually when you're working with an API, you not only want to download data, but you also want to make changes to the data that you currently have in the database. And in GraphQL, this is done via mutations. So here I have an example for a mutation with which we would create a conference. So we provide a couple of parameters to this mutation. And an important point about mutations is also that they not only write data, but they also always allow you, just like a query, to also retrieve data. So here in the payload of the query, we only specify the ID, but potentially we could also download the name, the city, and the year of the conference that we are just creating. Here, this wouldn't be really helpful because we already know these values. But if you have relations, and the conference would be related to more data, and maybe it wouldn't be a create mutation, but instead an update mutation or something like this. This could be really helpful that you also have the ability to query the data. And here is what the server response would look like. So again, the shape of the response of the server is identical to the mutation that we're sending over. We've got the create conference field and the ID field, and that's exactly what we get in the server response as well. All right, let's talk about the Apollo client that you can use when you're working with Swift and to work with a GraphQL API. And you can somewhat think of the Apollo client as a Hellomifier for GraphQL APIs. So it has three major features at the moment. And the first one is static type generation. And this really means that at compile time, the Apollo client is going to look at all the queries that you're sending over to the server, and it's going to generate corresponding Swift types for that. So previously, or usually when you're building an app, you kind of have to write the model types yourself. And when you're doing that, you have to decide whether you're really, really sure about the data that is going to be returned by the server. Then you don't have to make the properties on your model types optional. But if you have only the slightest insecurity about what your server is going to return, you have to make your model properties optional, essentially, because you don't really know if the server is actually going to return that, and otherwise you risk that your app is going to crash at runtime, and you really don't want that. So with GraphQL, you get all the security that all your data needs are always going to be fulfilled, and you don't have to work with optional properties anymore. The second part is caching. So the Apollo iOS client is going to maintain a normalized cache inside your application, so it'll store all the data, and you can specify fetch policies, so you can tell the client, or you can tell the Apollo client whether you wanted to make a request to the network or only to the cache. And it's going to maintain that cache for you and keep your data consistent. And especially with GraphQL, that's a challenge, because you potentially can send really nested queries that go multiple levels deep. So you first have to kind of normalize the data that you receive from the backend, and then you can put it in the cache, and that's how you achieve cache consistency. And then the third major feature is query watching. So this means essentially that you get automatic UI updates inside your application when data changes. So you don't actually have to use callbacks to update the UI manually, but instead the Apollo iOS client is going to take care of that for you. All right, before you begin using the Apollo client, you essentially have to do three things. First, you have to install the Apollo client inside your application. You can do this with CocoaPods or with Carthage. Then you have to download what's called the schema file for your GraphQL API. So each GraphQL API has a schema that clearly defines the capabilities of the API. And for the Apollo client to be able to generate the Swift types for you, it needs to have access to that schema. And that schema you can imagine as being like the contract between the client and the server, and everybody has to adhere to that. And the third thing is that you have to configure an Xcode build phase where you set up the static type generation. So inside that Xcode build phase, you invoke a tool that is going to look at all your GraphQL queries and generate the corresponding Swift types for you. In the example that I'm going to show right now, I have already done these three steps, so we can start by writing the code immediately. All right. Before we start, though, we actually need a GraphQL server, and that's what I'm going to create first, and I will show you a couple of examples for queries and mutations before we get into the actual Swift code. All right. So the first thing we need to do is we have to create our, is that visible? All right. So we first have to go and create our GraphQL server. What should the data model of our GraphQL server be? We can take a look at the model which I have prepared for this application. So we have two simple types. We've got the conference type and the attendee type. A conference has a name, a city, a year, and the attendees. And then we have the attendee type, which also has an ID, a name, and here we have a many-to-many relationship between the conference and the attendee type. So this is the data model that I specify for my application. And now I'm going to use the GraphQL CLI to generate the server. So here I'm just going to call GraphQL init. I pass the schema option, and in the schema option, I'm passing the models.graphql file, and now my GraphQL backend is created for me. All right, let's take a look around in that GraphQL server. So here I will start a playground. And a GraphQL Playground is comparable to a tool like Postman, for example, or the Advanced REST client. So it essentially allows you to explore the capabilities of your API in a very interactive manner. Let me just fix this. All right, so here on the left side, I can send queries and mutations to my API, and on the right side, I will see the server response. So if we would go and send the same query that we saw on the slide before, with ID, name, city, and year, we won't see much at the moment because we just created our server and we don't have any data stored at the moment. So let's actually go ahead and create some sample data in the beginning. And one quick side note for the demo, so I'm not going to attempt to do any real live coding. Instead, so I have prepared the code snippets, and I'm going to paste them into the project, and then I'll explain what exactly is going on. So let's go ahead and send a mutation to the server to actually go and create the first conference. And here I'm creating the SwiftConf conference in 2017 at Cologne. And let's also go ahead and create Swift Summit, which is going to happen in San Francisco. And if we now go back to the All Conferences tab and send our query again, we see that these conferences are now being returned by that query. Let's also go ahead and create an attendee so that we already have someone who is able to attend the conference. And now we want that this new attendee that we just created actually attends the two conferences which we created before. And for that, we are using a mutation that is called add to attendees, where we have to provide an attendee ID and a conference ID. And I first grab the attendee ID from before. So that's this one. And the conference ID first from SwiftConf. So now the attendee that we created before is attending SwiftConf. And now let's also make sure that she's also attending Swift Summit. All right. And now if here we could now change the query as well and ask for all the attendees and their names, and we would see that both conferences have now the attendee that we just created in their attendees list. And we also have like a more table-like view of the data that we currently have stored in the database. So here we actually have an overview of all the attendees and all the conferences which we created so far. All right. Now we're done with like the GraphQL part. Let's see how we can use it together with Swift. So here is my Xcode. Okay, so I actually quickly want to show the app that we are building. So now is demo time. Here is the app. So at first we have the register view controller where a user can provide their name. Here we are going to create the attendee in the backend. Then we have a list of conferences, and then we have a detail view where the user can select this conference and say that they are going to attend the conference. And the important part is that the UI here is automatically updating by means of the Apollo client, and we will see how exactly that works. So that's the app that we're going to build. Let's start. The very first thing that we have to do when we use Apollo is we have to instantiate a global instance of the Apollo client. And we do this by providing the endpoint for the GraphQL API. Let's see what that was. And if we need access to the endpoint, we can always get it from the GraphQL project right here. And I only have to replace the project ID. Let's see if it builds. All right. So here we have our global instance of the Apollo client that we can use to send queries and mutations to the backend. And because it knows the endpoint of our GraphQL API, we can just tell it, please send this query or this mutation to the backend. All right. So the first thing we want to do is inside the register view controller, we've got the save button pressed, the action right here, and this call to create attendee, which we now have to implement. And what we have to do here really is we have to send a mutation that takes the name that was given and sends that over to the server so that we can create this attendee in the database. And the way how we do this is by creating a new file with the GraphQL suffix inside our Xcode project. So here I'm just using the completely empty file template, and I'm calling it like the view controller where the mutations and queries that I'm about to write are going to be performed. So we are going to perform this mutation inside the register view controller.swift. So here I'm calling this register view controller.graphql. And inside this view controller, we add the mutation that we essentially have seen in the playground before with one little difference, and that is that here we're not hard-coding the value that we want to send over, but instead we're passing a variable because we can only ever decide at runtime what the name of the attendee is that we want to create. All right, so if I now build the project, the build phase that I was mentioning before is going to be invoked. So actually, let's take a quick look at this build phase and what it looks like. So here in the build phases tab of my project settings, we see that this check and run Apollo codegen script is invoked, and it takes in the schema.json. So this is also part of my project right here. So inside the conference planner project, we have the schema.json file right here. Not sure if that's readable, but here it is. So it takes in the schema as an input, and it essentially creates this new file that is called api.swift, which is going to contain all the Swift types that we need to send queries and mutations. So it already did that behind the scenes, but now I have to go and manually add this file to my Xcode project. So right-click on my project, add files to Conference Planner, and here we see the api.swift file that I was just mentioning, and now it's inside the project. And so we're not going too deep in what the code looks like that's actually generated, because that might be a little bit too complicated for this talk, but it essentially generates a number of really nested structs that you can use to send your queries and mutations. But the important point is that we now have this class here, which is called create attendee mutation, that takes a name as an argument, and that's really similar to the mutation which we wrote here. So what we have to do inside the register view controller now is we have to go and use this mutation and send it over to the server using the Apollo client. So let's go ahead and implement the create attendee mutation. We first start an activity indicator. Then we're instantiating the create attendee mutation, which I just showed in the api.swift file. We're passing the name that was provided. And then we're using this global Apollo instance that we have instantiated before. We're calling perform on it, passing the mutation, and then we can specify this callback here to actually do something with the result. The only thing really that's interesting here is that we are storing the ID of the new user, and the way how we do this is just with a very simple wrapper around user defaults. So if we set this variable, we also will save it in user defaults, and we return it from there. So it's just a very simple way to store the data for this demo, and then we perform the segue to the next screen. All right, so let's see if that actually works. Let's start the app. Provide a name in the simulator. And then we can also check here in the attendees list if that worked. All right, so here we've got the screen. I'm just putting in my name. Click Save, and we're moving to the next screen. If I refresh the attendees here, we see that this new attendee has now been created in the backend. All right, so the next task for us is to load all the conferences that we currently have stored in the backend. And the way how we do this is, again, very similar to what we did before. So we first have to specify a query. Then we have to run or invoke that shell script that is going to generate the Swift types. And then we can use these Swift types, pass them to the Apollo client, and do something with the response. So let's go ahead, create a new file again. This time we are using the query inside the conferences table view controller. So that's this one. And we're calling it conferences table view controller.graphql. And here is where we specify the query that we need to show all the required information. So on each cell, we want to display the name, the city, and the year of the conference, and the number of attendees that we currently have registered for that particular conference. All right, if I build the project right now, the build phase is going to be invoked again, so the Swift types will be generated. So here we now have this new type that is called all conferences query that will contain the data after it has been returned by the server. So let's actually go ahead and use this right now. We can take a very quick look at the implementation of the conferences table view controller so far. So that's a very standard implementation of a table view controller. We have this array. Currently, the type of the array is just any. So we'll see in a bit what we actually have to put there. Then we have a view.load where we set the title, we hide the back button, and we call this load conferences function right here that we still have to implement. And in prepare for segue, we'll have to pass the conference that was selected for the detail view controller. So let's go ahead and implement load conferences. And really all we do here is very similar to what we did before with the mutation. We first instantiate this generated type, and then we're passing this generated type to the Apollo instance, calling fetch, and retrieving the data retrieving the returned data from the result here, and then assigning it to the conferences array right here. But what is actually the type of this thing here? Now, this is now a little bit weird because the Apollo client is going to create really nested structures for the types that we have set. And here it's actually the all conferences query.data.allConference type. And we'll see in a bit how we can make that a bit nicer. But for now, let's go with this. So we now have the correct type right here. Let's also make sure that on the conference cell, we also have the correct type, because there we have the type not ready either. And then in the didSet property observer of our conference right here, we also want to make sure that the UI gets updated once the conference is being set. All right, so let's go ahead and run this. And if I didn't forget anything, we should now see the conferences that I created earlier in the playground in the table view. And there they are. So we've got the SwiftConf and Swift Summit, and both at the moment have one attendee, which is the attendee that I also created in the playground. So everything as expected until here, but what's really bothering me right now is this weird type right here. So the way how we do this how we can do this a bit nicer in the Apollo client is by using a GraphQL feature that is called Fragments. And I first quickly want to show what a fragment is again in the playground. So before we had this all conferences query here, but sometimes it can be convenient to define like reusable subparts of a query where you just have a set of fields that you hide with a specific name essentially. So here we are going to define a fragment that is just going to contain these fields and that we can reuse in different contexts. So here I can call this conference details on the conference type, and I put all the fields into that fragment that we had in the query before, and if I want to get the same results, I just use the ... conference detail syntax, so ... and the name of the fragment to achieve the same result. So really, what's happening here is that the server is simply going to replace this with the fields that we have specified here. And this GraphQL feature, these fragments, now allow us to work with the Swift types in a bit of a nicer way. So we can go ahead and define the same fragment we just saw in the playground, also in our .graphql file right here. So I go ahead and build the project. And now if we check api.swift, we just got a new top-level type that is called conference details. Here it is. So now I can replace this weird type that we saw before simply with conference details, and it'll just have the same properties. So let's go into the conferences table view controller, replace it here. Then in the conference cell, also replace it here. And then we just have to fix one more thing. And that's just a pattern that you are going to get used to once you start working more with the Apollo client, that now the conferences actually contain the fragment as properties as well. So we actually have to go and map over the conferences and retrieve the fragments from them. And that's what that looks like. All right. So we just retrieve the conference details and we can assign it, and now everybody should. So now it should just work in the same way it did before. All right, so here it's still running. And one more thing which I'm going to do right now for convenience is I'm going to add an extension on the conference details type, and I'm not going to do that inside the api.swift file, because this will get changed when we build every time, and if I make any manual changes to that file, they will be gone after my next build. So I write the extension in a different file, and this is just really a convenience function to know whether a particular attendee is attending a conference. All right, so now we want to implement the conferences detail view controller. If I click on a conference right now, we just see the values that I have specified in the storyboard, and now we actually want to go and pass on the real data to that. So inside the conference detail view controller, let's take a quick look at that. We have the conference that we're going to show, and then we also have the attendee list that is going to be rendered inside a table view, and down here we just again have a standard table view implementation. We don't know yet the type of the attendees right here, but we know that this conference is going to be of type conference details. All right, and then the is current user attending we're also going to set, so it's just again a convenience, or it's just a convenient way that is going to help us with the UI later on. All right, we are also going to implement the update UI function, where essentially we just take the data from the conference and assign it to the labels and to the button that we have on the details screen. And finally, if we navigate to that view, we actually have to go and tell the detail view controller which conference has been selected. So we do this right here and prepare for segue. All right. So this already should render the selected conference in the detail screen. So let's go ahead and run the app once more, select a conference from the table view, and see if we actually see the right data on the detail screen. So if I click on Swift Summit here, we see that now the Swift Summit is actually being rendered. We don't yet see the list of attendees, though, because for that, we actually have to make an additional query with some information that we want to display, because we also want to display how many other conferences each attendee is actually going to attend. So here is the query for that. Let's go ahead and create a new file for the conferences detail view controller. Conferences detail view controller.graphql. So again, we are following the same pattern. At first, we have to define the query or mutation inside a .graphql file. Then we have to build, and then we pass the generated type to the Apollo client. All right. So here is the conference query. So we are asking for a specific conference by passing an ID. And then we're also asking for the attendees, but for each attendee, we want to have the name, and we want to know how many attendees how many other conferences this attendee is going to attend. And that's exactly the information that we specify right here in the query. So now we can go ahead and load the attendees. So let's go to the detail view controller right here. We can now set the type. This is actually going to be of type attendee details, so the type of the attendees array that we want to display. Then we are implementing the self_row@index path in the table view down here. Essentially what we do, we just retrieve the correct attendee from the array, then we're assigning it to the label. It's not a custom cell, it's just like a standard table view cell this time. And we put the string on the detail text label, how many other conferences this attendee is going to attend. And then finally, we actually have to go and load the attendees, and that's what we're doing inside the load attendees method. So exactly the same way that we did before, we use the conference attendees query that was generated for us. We're passing the ID of the selected conference. We're passing this query to the Apollo client by calling fetch on it, and then we're using the results and assign them to the conference and to the attendees right here. All right, we've got two more features that we need to implement. The first one is we actually need to be able to change the attending status. So we have to implement like two more mutations to attend and not attend a conference, and then also the automatic UI updates using query watching. But we're almost done, so bear with me here. All right, so now we also see the attendees for each conference, so the query which we are sending is successful. So let's go ahead and create the mutations. Again, I prepared the mutations beforehand. We have to use them in the conference details view controller. So this is actually the same mutation that we saw in the playground before. It's the add to attendees mutation, where we're passing a conference ID and an attendees ID, and we have the same for removing, so we toggle the status, we toggle the attending status. Let's build the project so that the types are generated and implement our IB action with the correct mutations here. So in the conferences detail view controller, when the attending button is pressed, we want to toggle the state. So we first ask, is the current user attending? If it is currently attending, then we're going to send the not attend conference mutation. And if they already attend the conference, if they currently don't attend the conference, then we send the attend conference mutation. And we just pass the mutation to the Apollo client again. All right, so let's run this and see if it works. All right, so let's go. I'm now clicking the button right here. I will attend the conference. We don't really get any visual feedback, but from what we just implemented, we at least assume that the mutation was sent to the server. So let's do the same with Swift Summit. And if we now restart the application, we should actually see that the current user is now attending both conferences, and we don't see the red cross anymore, but instead the green check mark, because we're now attending the conference. And that's exactly right. And now both conferences also have 2 attendees, and they're both being displayed down here in the table view. So the last bit that we want to implement is the query watching, the automatic UI updates. And for that, the Apollo client provides the GraphQL query watcher that we have to use for that. That essentially will keep an eye on the cache and on the mutations that are going to be performed. And whenever a mutation is performed that touches an item from the cache, it can automatically infer which object in the cache it should update. And this will also automatically trigger a UI update. So let's go ahead in the conference's detail view controller. We want to watch the conference attendees query. Have to import Apollo for this. And then we only have to change the call to Apollo fetch right here, where we are passing the query. Instead of fetch, we're using the watch method on Apollo. And the result of that, we're assigning to the conference's attendees watcher, which I declared up here. Then we need to do one more thing, and that is we have to tell the Apollo client how it should identify the objects in our cache. And since we are using unique IDs for our objects, we can just do this. And that's just a really standard way of doing this. You don't really have to understand why we have to do it right now. So that should be good. And if we restart the app now, then we should see the UI in the details view controller update automatically, but we still don't see the UI in the table view controller update. So let's verify that first. If I now click here, I won't attend the conference. We see that we see that all the UI elements inside the details view controller update, but if we go back, we still have the attending status right here. So we also have to make sure that we're watching the second query, the all conferences query in the table view controller. That's what we're doing right here. Again, we're using the watch method, assigning the result of that to the all conferences watcher. And now, again, we have to import Apollo. And now the UI in the table view should be updating automatically as well. Incredible, this excitement here. All right, let's try. I will attend the conference. Detail view control is updating. Table view control is updating. The other way around, exactly the same. All right, so that's how it works. You've seen like the basic features. If that was a little bit too fast for you, which I can totally understand, like this was a lot for the session after lunch, I can recommend a couple of resources to you. So if you want to learn more about GraphQL, you can check out the How to GraphQL tutorial, which is going to give like a really basic introduction into GraphQL, like really the fundamentals, but it also has a lot of hands-on tutorials that you can do, mostly for web technologies at the moment though. So you don't have any native tutorials on that website, but there is the Getting Started with GraphQL tutorial on the Ray Wenderlich website. So it actually uses the same example, which I just showed in the demo. So it'll be somewhat familiar to you already. Then if you want to have like a more conceptual talk about what GraphQL actually is and why it's interesting for mobile, then I would recommend you this talk by the author of the Apollo client, actually, bringing GraphQL to iOS. And if you want to stay really up to date about what is happening in the GraphQL community and ecosystem, I can recommend you the GraphQL weekly newsletter and the GraphQL radio podcast. All right, that is all I have. Thank you so much for your attention. Happy to take questions.
All right. For the question, yeah, I need help from Andreas, but the first one is just here, so I can give you the mic.
Okay, one question I would like to know is how to 1, 2, 3 test. Okay, how you get persistency on the client if you like to, or is it not designed to have persistency on the client?
A really good question. So the Apollo client at the moment does not have persistency, so the cache is just in memory. But I think that there are at least some ideas in the community around the implementation of the Apollo client that are already trying to figure out ways how you can do this. But the Apollo client itself is still relatively young, so I think they released like the initial version last year in November, and right now they're on version 0.6. So it's still really young, and like for like a lot of use cases, you still have to find the right ways how you can solve these. And I think that persistency is part of that.
I've got a question. When I fetch data in an app, like a list of conferences, I usually have 3 features that I need in most cases. The first is filtering, the second is sorting, and the third is pagination. And filtering also, it has to have options like when we have attendees on conferences, I should also be able to say, hey, the number of attendees should be at least 5 and maximum 10, stuff like that. How does that work on GraphQL and on Apollo?
All right. So how you can achieve like pagination and filtering and sorting inside the API essentially. Like how do you get these kinds of capabilities? So with GraphQL in general, there is not really a solution for that. It really depends on the implementation, because GraphQL itself is only a specification for this query syntax that we saw, but it doesn't really tell you how you have to design your API. So that is still up to you as the API developer, how you want to expose all this functionality. I can tell you how we at GraphQL are doing this if you're using like the GraphQL API that we provide. So for each list that you're requesting, you can specify exactly these parameters that you were just mentioning for filtering, for ordering, and for pagination. So here I could now go and specify a filter. If I wanted to have the conferences which are happening in Cologne, I just send like this query with this filter here, and it would only return SwiftConf, but not Swift Summit anymore. And we have more of these these filtering capabilities here, so you could also have like a string contains or is inside an array or something like this. So we really provide you with all these mechanisms out of the box, and if you want pagination, exactly the same. We support limit offset pagination, so you could skip the first 100 and then load like here after. And if you combine skip and after, you essentially get this limit offset pagination capability. Does that answer your question?
The first part, and the second part is if Apollo supports these things like pagination.
The Apollo iOS client, I don't think that they really support that at the moment, so you'll probably have to figure out some way how you can do that with it. I think on the web they are already a bit further, so I think their pagination is supported by default. I don't think that's already implemented in the iOS client.
Okay, thanks.
Yeah, maybe one last question because we're running a little bit of time. Keep the others for the panel.
How about versioning of the schema?
That's a really good question. Right. So Facebook actually, when they announced GraphQL, what they claim is that since they started using GraphQL, they have never really needed to version their GraphQL schema. So the GraphQL schema defines the API, and they said they don't really have to version it, which for most applications is not going to be feasible. So you want to have some kind of versioning system. And what's really nice about GraphQL is that on the server side, you can have really good analytics about what data is being requested. So when you see that specific fields are not being requested anymore, and you can tell the clients that you know are accessing your API, hey, we're going to deprecate this field. You can put that into the schema so the clients are aware of it. You can know when clients are not accessing specific fields anymore, and then you can remove these fields. As the short answer, we can talk a bit more about it after the talk afterwards.
All right, we keep the other question, keep the question for the panel, Manu, because we'll speak about this stuff again later. For the moment, I will ask you to give Nikolas a round of applause.
Thank you. Okay, and I have stickers as well, GraphQL and GraphQL stickers if you want some.
Stickers. And yeah, and go outside for like 10 minutes or something, and then we'll come back later with James. All right.